Hey folks, how's it going? This is Mr. Murray coming to you with a due now for Course 1 Honors for Wednesday, May 20th, 2020, and welcome to what I like to call Review Wednesday. And here on Review Wednesday, I call it this because we want to start remembering to cover some of that content that we might have learned in the past because we don't want to forget that, okay? One thing I want to note is that, and obviously I can't go back to all my old videos and change this, but I wanted you to know that the solving practice is still available. Okay, it used to be called factor.willnot.fail. Right, I used to say, oh guys, make sure you're doing your practice at factor.willnot.fail. You may have seen on the website, on the Google Doc, that I've changed that to solve.willnot.fail. So the factoring website will only let you do factoring practice. So this is if you want to just practice factoring. Okay, the solving website, what the solving website does is factoring, not only factoring, but also solving. Okay, so you get all kinds of practice with the solving website. Okay, and so that's where you would find the stuff that you used to find at factor.willnot.fail. In any case, we have three equations here. N squared minus 12n plus 2 is 30. 4y squared plus 7 is 103. 16x squared plus 70x plus 169 equals negative 34x. So what I want you to do, pause the video, find any solutions that are there, and then when you're ready, unpause, and you can see what I got. Alright, so let's take a look. So I've got n squared minus 12n plus 2 is 30. So this is a situation where you do need to use factoring, and that is because of the existence of the b value here, right? We don't have any way to work with this when we have square roots, and we're still probably not going to end up getting to that till next year. It's all right. So I need to use factoring. So the first thing I do need to do is I do need to make the expression equal to 0, because you can't factor until it's equal to 0. Please make sure you did that, otherwise the problem might have seemed very, very difficult. Understandable. I love 28 because it's a perfect number, which means that all of its factors, I believe except 1 and itself, add up to it. So if you take 14, let's see, I think 1 you might count that. 14, 7, 4, 2, yeah, and 1. If you take 14, 21, 25, 27, 28, if you take all of 28's factors and add them up, except for itself, it adds up to the actual number. So it's a perfect number. Alright, it made me feel better about turning 28. So now I want to factor this. So I know that I'm going to put my n squared in here and my negative 28 in here. So that means I need to have an n and an n. And now my goal is to multiply to negative 28. And so what's cool is, by having my little talk about how it's a perfect number, I've basically locked down all the possible factor combos. 28 and 1, 14 and 2, 7 and 4. Now my goal is to multiply to negative 12. I'd rather add to negative 12. I also need to multiply to negative 28. So that tells me that I need a positive and a negative, because I got to multiply to a negative. So that's a good thing to know. And I noticed that if I do negative 14 and positive 2, that I get 2n minus 14n, which is negative 12n. So I get n minus 14, n plus 2 equals 0, which means n is 14, or n equals negative 2. Remember here, I want to know what's n equal to. If I give you an equation, your answer should be something equals. If I give you just no equation, it should be the things being factored, generally speaking. So you have to look very careful for the directions. Here the directions are solve, so I want solutions. Okay. Next problem There's probably a couple ways you could do this, but there's a potential that if I subtract 103, that this could be factorable. I see that 4y squared is a square, and I see that if I subtract 103, I'm going to get a negative number, right? Because it's going to be 7 minus 103. But if it's not a difference of squares, then there's no way for me to factor it. And I'm not saying it's not factorable, I'm just saying we don't have the skills to do it. So the challenge here then is that I think what I want to do is I'm just going to want to use probably just use square roots. So I'm going to subtract 7 on both sides. This is an important skill, and you never know when you can just simply solve a problem using this. So I do 103 minus 7, and that brings me to 96 because I have 3 and then another 4. Now I'm going to divide by 4 to get y squared alone. 4 times 2 is 8, remainder 1. 4 times 4 is 16. And now we need to take the square root on both sides. So y equals, it's a positive, so there will be solutions. In fact, there will be 2 plus or minus the square root of 24. Now you do have to take it further because 24 is 4 times 6. So the square root of 24 is equal to the square root of 4 times the square root of 6. And the square root of 4 is 2. And the square root of 6 we have to leave as is. Okay, this is one of the laws that we learned this year involving roots. And believe it or not, next year, when we talk about rational exponents, right, we'll learn that square root of 6 is equal to 6 to the 1/2. Because if you think about it, 6 to the 1/2, what would I get if I did 6 to the 1/2 times 6 to the 1/2? Well, look, when you multiply and the base are the same, you add the exponents. 1/2 plus 1/2 is 1. But 6 to the 1 is equal to 6. So this is a number that when you multiply it by itself, gives you 6. But that's what the square root of 6 is. So basically, there's got to be some kind of connection there, right? All right. So the last thing we're going to do is we're going to do this one, just a more complicated one. We are going to have to go ahead and factor. So I will move 34x over to the other side. I'll have to add because it's being subtracted. So I've got 16x squared plus 104x plus 169 equals 0. Now, hopefully, I'm hoping, first of all, you set it to 0. The next thing I'm hoping is that you took a look at this and potentially saw something. You saw that, first of all, I know that 169 is 13 and 13. And maybe if you were breaking down the factors, you would have also found that. And I noticed that 16 is 4 and 4. So it's possible that I've got a difference of squares, or not a difference of squares, a perfect square. So I'm not saying that they are. What I'm saying is, let's try that as a possibility first. Because I know that I'm going to have to do some combination. So maybe this will be it. And if it is, great. And if it's not, try another. Now, I noticed that this here is positive. And this here is positive. So I'm going to be choosing a positive 13 and a positive 13. Because remember, we need to add to a positive. If these were negative, we'd get negative numbers and it would add up to a negative number. 13 times 4 is 52. And 52 plus 52 is 104. So we have 4x plus 13 times 4x plus 13 equals 0. And I would like you to rewrite it as follows. I would like you to go ahead and rewrite that as squared, because we know when things are multiplied by themselves, we're squaring them. Okay? And then finally, x is equal to, well, let's do it like this. 4x plus 13 is equal to 0. Right? Now you could imagine, how. Think about how I would get rid of this square root. If this was just y squared equals 0, think about how I would get rid of the square root, right? You would take the square root of both sides. So the idea that we're going to start talking about next year is we're going to say, look, if I could take this and turn it into a square, then I could just take the square root of both sides and it would turn in to 4x plus 13 equals whatever's left on the other side. In this case, we have to make it 0. But what I'm trying to say is, what if we did not have to always make it 0 before we started to work out problems like that? Okay? Because we might have another way to do this. But what we know, because it's equal to 0, is that there will only be one solution, and we'll find it by subtracting 13 and then dividing by 4. So you get negative 13 over 4, or I would take negative 3.25, because it would be 3 1/4. Okay? So again, just breaking it down. First, on our first one, we had a equals 1, but it wasn't equal to 0. So we just remembered we have to set it equal to 0. We use the box, and we make the factors, and then we set each factor equal to 0, and we get our solutions. In the second one, we had to solve by square roots. First of all, we knew it was possible because there was no b value. It was just a y squared and a number. So that made it possible. Once we knew that it was possible, we just went ahead and isolated the y squared by subtracting 7 and then dividing by 4, right? Subtracting 7 gave us 96 on the right. Dividing by 4 gave 24. And then all we did was take the square root. And what's so beautiful about this is that you take a problem that's a squared where we have no idea what to do sometimes, and it's so difficult to figure out what's going on, and you reduce it to a linear equation that we've been solving for quite some time. So that's what's really cool, is how everything that seems complicated in some way generally ends up being boiled down to stuff that's the most fundamental things that we've been working with for quite some time. Okay, then the last thing you just got to remember here is making sure that if you ever have a square root, you do need to simplify it. So I would not accept the square root of 24 left for full credit because it's not simplified. So you do need to rewrite that as 2 root 6. Let me know if you need any help with simplifying roots. Okay, lastly, we had a situation where a was more than 1. So again, because of the b value, we were inclined to use factoring. So we first set the right hand side to 0, and then we noticed, wait a minute, a and c are both perfect squares. Okay, so a is 4x squared and c is 13 squared. And so what we did is we set up our box and we said, hey, you know what, worst case we're wrong, but let's try it. And it turned out, yeah, it's a perfect square. It's 4x plus 13 squared. Since it's a perfect square, it only has one solution. So we just drop the square. We just worry about that 4x plus 13. And we get our one solution of negative 3.25. If you're able to get the answers, congratulations. Keep working at the stuff. Make sure you're checking out today's lesson materials because we're going to keep pressing forward with the exponential modeling. But best of luck. Don't forget to love math. And remember, folks, you can do it.